Welcome back, everyone. Today, in our session, we are going to discuss Cayley-Hamilton theorem. This is a very important theorem in algebra. The basic idea of Cayley-Hamilton theorem is that every linear operator satisfied its characteristic equation. Now we know every matrix is also a linear operator, so this statement is true for the matrices also. Okay, so let us start the statement and then we will try to prove this also. So theorem says, this is theorem 5.23, and this theorem defines Cayley-Hamilton theorem. This theorem says, let T be a linear operator on a finite dimensional vector space V, and let Ft denote the characteristic polynomial of T. Okay, then when we replace this lowercase t by uppercase T, that means the linear operator T, then the resultant linear operator is equal to T naught. यहाँ पे T naught represent कर रहा है zero linear operator, where T naught is zero linear operator. That is T naught of V equal to 0 for all V belongs to V. ठीक है, हर एक वेक्टर V की T नॉट इमेज 0 पर जा रही है, इसलिए हमने इसको जीरो वेक्टर बोला है. ठीक है, particularly we say T satisfy its characteristic equation. Okay, which is equation f of t equals to 0. So this is the statement of Cayley-Hamilton theorem, and proof is quite simple, in which we will use the statement from the last lecture. So let us write the proof. Proof says हमने बेसिकली ये शो करना है कि जब भी हमारे पास कोई भी लीनियर ऑपरेटर होगा वो अपने इस कैरेक्टरिस्टिक पॉलिनोमियल इक्वेशन को सेटिस्फाइड कर रहा है. दैट मीन्स वी नीड टू रिप्लेस दिस टी बाय कैपिटल टी. ओके, बट ये जो जितना भी डिस्कशन है दैट विल बी सिंपल व्हेन वी यूज द कंसेप्ट ऑफ टी साइक्लिक सब स्पेस. ओके, let us see how this makes simple. So let us show we will show that f of uppercase t is equal to 0 for all v in v. ठीक है, now if t is a linear operator on v, then so is f of t. अगर t लीनियर ऑपरेटर है तो उसका अगर हम इसके लिए कोई भी पॉलिनोमियल अप्लाई करेंगे, t का हर एक पॉलिनोमियल भी एक लीनियर ऑपरेटर ही होता है. दैट मीन्स दिस एफ टी इज ऑल्सो अ लीनियर ऑपरेटर. ओके, देन f of t of 0 is equal to let me write this as v. ओके, एफ टी ऑफ 0 इज इक्वल टू 0. ये क्यों है? क्योंकि हर एक लीनियर ऑपरेटर के लिए जीरो वेक्टर की इमेज हमेशा 0 पर ही जाती है. ठीक है. नाउ you can choose any non-zero vector, and the moment you have a non-zero vector you can talk about t cyclic subspace generated by that non-zero vector. Okay, so let us consider that. So let v belongs to v such that v is not equals to 0. Then we can think of t cyclic subspace generated by this v. Okay, and let this subspace is w and dimension of w equals to k. अगर w t साइक्लिक सबस्पेस है और इसका डायमेंशन k है, then we have that a naught, we have that there exist scalars a naught, a1 and so on ak minus 1, such that a naught v plus a1 t of v plus a2 t square of v plus and so on plus ak minus 1 t to the power k minus 1 of v plus t to the power k of v will be equals to 0. Okay, let us call this equation as equation number 1. Okay, also using these scalars we can write the characteristic polynomial of the restricted of linear operator tw is gt equals to -1 to the power k. ये आपको याद रखना है. Then a naught plus a1 t plus a2 t square plus and so on plus ak minus 1 t to the power k minus 1 and plus t to the power k. Suppose this is our equation number 2.